Hi, it's Carly McAvoy. I'm working with a TI-84 Plus calculator through an example for hypothesis testing. We will use the TI-84 to help us find the area under the curve in a two-tailed test. So this is an example where someone bought a pack of seed that was supposed to yield 27% pink flowers. When they bloomed, she counted them and found 433 blue flowers and 138 pink flowers. Using a significant level of 0.05, test the claim on the seed pack. So the claim is that 27% of the flowers will be pink, so P equals 0.27. Then, since the claim includes an equality, that's our null hypothesis, and we designate the null hypothesis with the sub-zero here, and the alternative with a 1. Sometimes you'll see an A there instead. The alternative is equal to equal is not equal to. So since they said equal, then alternative is not equal to, which means it could be less than 27 or more than 27. Either one disrupts their hypothesis. And so that means we have a two-tailed test. We want to find the test statistic, and this is how you find it: p hat minus p over the square root of pq over n. So we know P is 0.27, we said that earlier. We know that Q is 1 minus P, so if you take 1 minus 0.27, you get 0.73, so that's easy. What is our N? Well, we know that if we add the 433 and the 138 together, that would be our total number of flowers, so that's 571. The ones that were actually pink in this case were 138, and to find our P hat, we take that 138 and we divide it by the total number, which was 571, to get 0.241681. Now we have described all the variables that we have in this particular equation. P hat minus P, so 0.24168 minus P, 0.27, over the square root of PQ, 0.27, 0.73, over N, and that equals negative 1.52. And then it says use technology to find the area to the left of 1.52. So the way your calculator works is when you put in a value here for negative 1.52, it's going to show you the area under that curve to the left this way. So this is what you're going to enter, and I'm about to do that and show you what you get. We should be getting 0.06426. So let's look at that. So how we're going to do this is I do have a video about how to do this as well. I wanted to show you how you would use it inside of a larger problem. So we have this is on. I'm going to just clear all that screen, and then I'm going to hit second function, VARS, or distribution. And for this we want the normal CDF. So I'm going to go down to 2 and hit enter. And my lower value is negative 1, e to the 99, and my upper value is negative 1.52. So negative 1.52, that was my test statistic. I'm going to leave the mean as 0 and the standard deviation as 1, and I'm going to paste this here. And I put that all into the calculator and hit enter, and I get that 0.06425 value that I had on the other one. So that's how you use your calculator to find that value. To finish off this problem, though, we're supposed to decide whether we're testing this hypothesis. And also, we know that this is two-tailed. So once we get the 0.06426 that we got on the calculator, we have to think about it's that amount on the left and it's that amount on the right. So I need to take that amount times 2 to get this 0.1285. Now we want to compare the p-value that we just found to the given significant level, which was 0.05 they told us up here. Well, you can see that 0.1285 is greater than 0.05. The p-value is high. That means the null will fly, and that means we failed to reject it. We think that they were correct. So in this case, the null hypothesis was our claim. Since we failed to reject it, we cannot find fault with that supposition that the pack contains 27% pink flowers. So we would say there is not sufficient evidence to warrant rejection of the claim that 27% of the flowers will be pink. You don't say we accept the claim, you say you reject it or you fail to reject it. All right, have a fantastic day.